Hello guys and welcome to Class for All channel, another video, Quadrilaterals for class 9. Right, in this chapter we're going to cover the basics of quadrilaterals and we're going to cover a few questions and some different questions in another textbook. So first of all, we'll discuss a quadrilateral. What is a quadrilateral? It is basically a four-sided polygon. This is a polygon, okay? A polygon is any figure with number of sides. So if a polygon has four sides, 1, 2, 3, and 4, it's a quadrilateral. That's the definition of quadrilateral. This is what we must know. All right. Now, the first thing we're going to learn is the angle sum property. It's basically the sum of all the angles in quadrilateral is 360. Okay. Right. Angle sum property. Right. So you should know this. The sum of all the angles in a four-sided figure is 360. So there can be only four angles because they're four sides. So that's why sum of four angles is 360 degree. All right. So if I have, let's say, one quadrilateral, it's a four shape. It can be any shape, right? If I have 1, 2, 3, and 4, the sum of this will be 360. Okay. This you can take for a fact as a theorem. All right. Or else let's do a brief example. They're saying the ratio of the angles in a quadrilateral is 1:2:3, 1:2:3:4. So find all the angles. So we'll just put an X in all because they cannot be 1 degree, 2 degree, 3 degree. So we'll put an X. And because the sum is 360, right? So what are we going to do? We're going to add them 10x, because if we add them, it's 10x is equal to 360. Therefore, X is equal to 36. And so the first one will be 36. Second one will be 72. And third one will be 108 degrees. And the last one is 144 degrees. Right? This is how you find them, the angles, when they're given just ratios. All right, so let's discuss the types of quadrilaterals. So the first one is trapezium. And the definition of a trapezium is it a quadrilateral? Yes, it's quadrilateral. Four sides are there, having one pair of parallel sides. That means any two sides are parallel. Either these two sides are parallel, or if I had to draw one like this is parallel. Okay, so any two sides are parallel, it's a trapezium. Another one would be isosceles trapezium, which basically means the non-parallel sides are equal. So if this side is equal to this side, these two sides are equal, then it became a isosceles trapezium. All right. You got the first one's a trapezium. Let's discuss the second one. Okay, the second one is a parallelogram. It's basically the opposite sides are parallel. That means this side is parallel to this side, and this side is parallel to this side. Okay, you have all parallel sides, and a parallelogram, the same parallelogram having all sides equal, is known as a rhombus. Okay, it'll be known as a rhombus when the same figure has this is parallel, this is parallel, this is parallel, and but if I just add one thing, that this is equal to this is equal to this, all four are equal, then it becomes a rhombus. Okay, because we know what a parallelogram is, it's easy to know what a rhombus is. And there are some properties in each of them, but first let's discuss what each is. Okay, now a parallelogram forms the basis of all the other shapes. So a rectangle is basically another parallelogram whose one or each angle is 90 degree. This is 90, this is 90, and this is 90, and this is 90. But it's also parallelogram, therefore these opposite sides are parallel to each other. A parallelogram with one angle 90, that means all angles 90, is a rectangle. All right. So talking about a square is nothing but a rectangle with pair of adjacent sides equal. So if I have a square, and obviously all angles are 90 because it is a rectangle, but this side is equal to this side, and because this side was equal to this side is also equal to this side, and all sides are equal, it became a square. Because in rectangle, the opposite sides are equal, right? This side is equal to this side, and this side is equal to this side. And now if I keep adjacent sides, these sides equal, all of the sides became equal, right? And that's why it's a square. Okay, let's talk about a kite. A kite is a quadrilateral if it has two pairs of equal adjacent sides, which would be this and this. They're equal and they're adjacent, and unequal opposite sides. That means these two sides are equal. That means this is adjacent to this side, so they're equal, and this is adjacent to this side, so they're equal. But the opposites means this and this are opposites, and this are opposites, right? They are unequal. Then it is known to be a kite. All right. So let's talk about some properties of parallelogram. So we draw a parallelogram. Okay. There's opposite sides parallel, obviously. And the first one is that opposite sides are equal. Okay. This side is equal to this side, and this side is equal to this side. Okay. This is one first theorem. And the second theorem, if I drop a diagonal, it divides these two triangles, triangle 1 and triangle 2, to be congruent. Why? Because they're this side equal, this side equal, side. And in another thing of parallelogram is that the opposite angles are equal. That means this angle, that the opposite angles are equal. This angle is equal to this angle. So angle side angle theorem, axiom, you can prove these two triangles are congruent. Or you can also do that alternate exterior angles is this angle is equal to this angle, and this angle is equal to this angle. To know about congruent triangles, watch my previous video which discusses our triangles and congruency. One more thing about the parallelogram is that the diagonals bisect each other. So if I draw a diagonal AC and BD, they bisect each other. Okay, that means this is equal to this and this is equal to this. That means these two sides are equal and this sides are equal. This comes in handy when proving this triangle is congruent to this triangle, or this triangle is congruent to this triangle, because you have vertically opposite angles here. So you can do side, angle, side, okay, SAS theorem, and you can also do alternate exterior. So once you know all these properties, it's easier to prove it, okay? All right, so we discussed all the properties of a parallelogram. Now let's talk about one more thing about parallelogram is that these angles, these two angles are supplementary. That means the sum of x and y is 180. Why? I mean, if you studied the chapter lines and angles on the previous videos, I've discussed what lines and angles are. These two lines are parallel, and imagine this to be the transversal between the two parallel lines, okay? And these angles, x and y, they become co-interior angles. This is the proof of why these two angles are supplementary. And obviously this is x and this is y. This is the theorem of the parallelogram. Let's do a quick question. It says that the question says that angle D is given to be as 115. So find all the other angles. So what we can do quickly is that the opposite angles are equal. So this is 115. And since these angles are supplementary, this would be angle A would be 180 degrees minus angle B, because they're supplementary, and angle A would not be nothing than 65 degrees. And since if this is 65, the opposite angle means C would be equal to C, angle C, okay? So this is 65. So this is how we found all the angles of a parallelogram. So even if they give you one angle, it's easy to find all the other angles of a parallelogram. That's the beauty about it. So as you can see, we have a question up there. It's been given that B is equal to AB, and they've also given that ABCD is a parallelogram. So what we need to prove is that BO is equal to C. That basically we need to prove that ED bisects BC. Okay. So the first step we'll do that, we'll write that ABCD is a parallelogram. This is short form writing parallelogram. Okay, so AB is equal to DC, because remember parallelogram opposite sides are equal. Okay, and since this is possible and AB is equal to BE, so BE is also equal to DC, right? So let's mark that. And now we have this. So now if you take in triangle BOE and triangle, what is that, COD, we also have over here. So as you can see, I marked angle 1 and angle 2. So angle 1 is equal to angle 2 because of alternate interior angles. Okay, since it's a parallelogram. And second one would be, if you see this angle 3 and 4, they're equal because they're vertically adjacent, right? Sorry, vertically opposites. So they're also equal. And what we just proved now is that BE is equal to DC, right? Which is this side is equal to this side. So what we can see is angle side, I think. So these two triangles are congruent by angle side axiom. And since these two, as we proved this part, and since these two triangles, this triangle and this triangle congruent, this side, which I've just marked with red color, they also become equal because of CPCT, right? This side CO and BO. They become equal because of CPCT. And since I proved that this angle is congruent to this angle, therefore BO is equal to CO, and that is proved. All right. Make sure you write this statement that B is equal to CO because of CPCT and the both angles are congruent. I have not written there, but you need to write them, and then that's how you prove it. So before you watch this video, you need to watch the video about triangles and congruency. Then only you'll be able to solve the quadrilaterals and the questions on this chapter. Okay, so as you can see, the questions are right in front of the board, and we need to prove that BC is equal to half QR. So as you can see in the, as you can see that we need to prove that BC is equal to half QR. So it's been given the question also that A, Q, and B as well as C is a parallelogram. To mark that in perspective for you, I am talking about this quadrilateral. It is a parallelogram. All right. Since they have given the question, and therefore BC is equal to AQ. All right, so they're opposite sides of parallelogram, and also ARCB is a parallelogram, and BC is equal to AR. Put that in perspective, ARCB, it's this one. Okay, that's ARCB, and BC is also equal to AR since they are opposite to each other. And therefore, if BC is equal to AQ, and so these two are also equal, right? Now, since we got that, now watch this carefully. EQ is equal to AR, which is also equal to half of QR. Isn't that right? Because if you see AR and AQ are equal, and RQ is composed of AR plus AQ, and since these two are equal, I can also say that RQ is equal to 2AR. And if I take the 2 there, AR is equal to half QR. That's how I proved it, if you are wondering. Okay. And since I proved that, and I know that AR is equal to BC, so I just put BC over here, and I get BC is equal to half of QR. That's a very simple question. I hope you all got it. Please say in the comment that you have gotten it. Thank you. Okay, so you can see a question that we show that it's a proving question, as you can see. So we have to prove it. The diagonals of a square are equal and they bisect each other at right angles. So the first thing to do is to draw a square. All right, let's name our square ABCD. And let's draw the diagonals. All right. And let's name the meeting point of the diagonal. So now we need to, let's start it. So we need to prove that AC is equal to BD. Okay, so the diagonals are equal, which AC and BD. And we also need to prove that this angle between them is 90 degrees. So let's do that first by starting in triangle BAD. Please look at the diagram if you don't know what the triangle is. And triangle CDA. This triangle and that triangle. Okay. So we have BA is equal to CD since it is a square. All sides are equal. Remember the properties. And angle BAD is equal to angle CBA. Both are 90 degrees. Remember, a square is nothing but a rectangle with all sides equal. And all angles are 90 degrees. Okay. And obviously AD is equal to AD, which is common. So we prove that by SAS axiom, these two triangles are congruent. And since we have proved this, by CPCT, AC is equal to BD because they are part of the congruent triangles. Please watch the video congruent and its triangles. If you do not know what this means, I've covered in my previous videos. I'll be attaching that video link at the end of this video as well. All right, so we've proved that the diagonals are now equal. What we need to prove is that the angle formed in angle AOB or DOC is 190 degrees. Okay, one interesting thing, since every square is a parallelogram and the diagonals of a parallelogram bisect each other. So this is equal to this, and this is equal to this. To put in perspective, OA is equal to OC because it's bisected, and OB is equal to OD. This is in the parallelogram properties. Okay, I'm not going to put that, but you should know this. We explain this in the parallelogram properties. And now let's look at the triangles AOB and triangle COB. So AB is equal to CB because it's a square. OB is equal to OB is common, and OA is equal to OC as we just saw over here. And since I've done this by SSS axiom, these two angles are congruent. Put that in perspective, I'm talking about this angle number 1 and number 2, these two angles. Okay, now I've done that. Now let's talk about proving. So angle AOB is equal to angle COB because it's CPCT. They're parts of the congruent triangles. Is this angle and this angle, and they're also vertically opposite. Okay, sorry, I'm talking about this. Angle AOB is equal to COB because this triangle will also congruent to this triangle. All right. By similar method, you can see that they're common and the angles are equal. Okay. Anyways, so these two are there. So if I add, it's a linear pair, right? If I have to add these two triangles, they're supplementary, so they should give me 180. And since they're equal, so I can do angle AOB is equal to 180. And by this angle AOB and by this angle AOB is equal to 90. And since that is 90, angle COB is also equal to 90. And angle COD is also equal to 90. Right? Which is also equal to angle AOB. And since I proved that all these are 90, put that in perspective, I'm talking about this angle. 90, 90, 90, and 90. All right. That is how you prove that the angles bisect each other at right angles and the diagonals are equal. All right, guys, that is all for today. This is part 1 of quadrilaterals. It's a big chapter. We're going to have part 2 as well, which will cover the rectangle, rhombus, right, and a square. That is a diagrammatic representation of a rhombus. Can you guess which is which? Number 1, number 2, number 3. Write in the comments below which is a rectangle, which is a rhombus, and which is a square. And this is just a fun exercise. Part 2 will cover the properties of all these three. And as usual, do not forget to leave a like, subscribe, subs, I'm going to write subs, like, subs, and share. And as always, study. All right. Thank you.